On behalf of the CSIAC, we would like to thank you for viewing this podcast. We hope you found the content useful and informative. If you would like to provide us with feedback, please comment on this video or visit our website at www.csiac.org, where you can also find additional content to review. Thank you. Welcome to the CSIAC podcast series. In this episode, we continue our exploration of entity resolution for the cyber domain. The cyber domain is characterized by many disparate sources of information about real-world hosts. When selecting data sources for host cataloging and entity resolution, evaluate a data source's utility by 4 criteria. First, authenticity. How truthful is the information? Second, quality. How easy is it to extract the information? Is there a lot of noise? Third, coverage. What fraction of the population does the data source cover? What fraction of time? And finally, cost. Is the data readily accessible? Does it require deploying new sensors? Does it have side effects on the network's operation? There are several dimensions across which the available data sources can complement one another. They contain different attributes or field types. Different sensors generating data streams target hosts of different systems, platforms, and locations. Data streams collected at different intervals from multiple sensors can provide a more continuous and complete view of the host population over time. Different sources of data are reliable over different time intervals, and the reliability can vary. Combining data sources is challenging because it must have a matching field type, time interval, and visibility to the same host. The number of fields in a data source can get very large, while individual records can be sparsely populated. Different types of events may be reported with a different subset of fields. Overcoming these challenges is the primary goal of this research. A prototype system was developed to catalog unique hosts on a network along with a timeline of network events associated with each host. In contrast to entity resolution in medical, intelligence, or law enforcement, equating an entity in one record to a corresponding entity in another typically does not have a lot of support from overlapping values in the data. Experiments with different mechanisms for combining evidence from multiple records was conducted. A host segment, which is a coalesced timeline of log events describing a network connection session, is defined by 4 variables: tstart, tend, IP, and MAC. The values of these variables are pulled from different data sources. Ideally, tstart and tend are extracted from sources that indicate the initiation and termination of a session. The challenge of ER lies in aligning different network connection sessions to the same underlying host in the physical world. Extensive use is made of the fields and records that fall into a host segment's time interval to provide support for ER between host segments. A record is associated mainly to a segment if it contains that segment's IP and/or MAC. A pipeline to guide the development of the cyber entity resolution prototype was designed. A single entry in a log file is referred to as an event or a record. The pipeline takes events as input and produces timelines of unique hosts as output. It consists of 7 stages operating on a continuous stream of events. New events are ingested and parsed. Useful attributes are extracted and stored into a database. Segments are constructed by chaining events with the following constraints. First, a segment consists of one or more events with identical IP and MAC. The first event is a connect event or a poll event indicating the network interface is live. The last event is a disconnect event or a poll event. And finally, no 2 segments with the same IP and or MAC can overlap in time. Given that cyber events happen at a specific time, while host segments are defined by a time interval, 2 strategies could be used to enrich the segments with additional event data. First, sample the collection of host segments at discrete intervals, called snapshots, and estimate the host variables at the time of these snapshots. The second is to integrate or aggregate all events that occur within the segment interval and enrich the host with all this information. Snapshot-based enrichment represents an instantaneous state of the network consisting of a set of active segments and their features at snapshot time. From the perspective of a cyber defense analyst, a key capability enabled is the ability to have access to a timeline of host segments on a network in the form of a searchable repository. A prototype repository called Bitbook that continuously ingests available data streams was implemented. The tool is written with a Python backend to handle log ingestion, segment construction, and snapshot construction. The records are then stored in a SQL-compliant database accessible by the front-end web application. The machine learning algorithm used to classify host record pairs in this experiment was the generic entity resolution algorithm. Each record consisted of the segment IP, MAC, start time and end time, enriched with host name, user, operating system, and location. To illustrate the Bitbook tool and its performance, 2 experiments were considered. First was the ability to identify multiple host segments using Zeek, a monitoring tool, to log data from a cyber exercise as compared with an alternative blocking technique, node to bits. Second was a proof of concept of end-to-end ER on hosts across 2 snapshots using server logs from an enterprise network. 4 Zeek logs from the 2017 National Collegiate Cyber Defense Competition Championship were utilized. Each team was provided a core network consisting of 7 servers and 6 workstations with various operating systems. Network traffic from a particular date and time were compared. Unfortunately, uniquely identifiable ground truth data was not available. Also, it did not appear that Kerberos was used as the primary authentication protocol. It was found that node to bits, while promising in its generality, did not easily extend to discovering unique hosts from the log data over the same period as was used for Bitbook. The generic entity resolution algorithm was used to classify host record pairs in the initial experiment. In the short span experiment, two additional features were left in the feature set: a unique identifier field for each record and the snapshot time of the record. The preliminary results are promising and demonstrate the feasibility of constructing a timeline of host activities. However, it is important to recognize that the data used in these experiments were selected to include hosts for which there existed clean endpoint management records. This resulted in a collection of hosts that is more homogeneous and has a more stable collection of enrichment properties than would generally be found in a complete network environment. This entity resolution methodology should be tested against an ecosystem of hosts that includes servers, routers, embedded computing infrastructure, mobile platforms, and a variety of other host types. Having demonstrated the utility of organizing disparate log data into host segments and snapshots, the next step should be to perform entity resolution between the host segments. This would hopefully ameliorate the long run times due to the complexity of comparisons in the supervised learning problem. The machine learning step should be tightly integrated with the entity resolution tool to supplement the snapshot information with comparisons to a running catalog of discovered devices in order to enhance the cyber situation awareness. This would make it easier for an analyst to confidently use the tool in connection with other cybersecurity tools, such as alerting tools or vulnerability scanners. In this podcast, we presented a cyber entity resolution approach to discover and resolve hosts on an enterprise network, given access to either server logs or network logs produced by Zeek. A blocking technique that defines host segments as intermediate entities was used. An intermediate entity for collections of host segments at discrete points in time was introduced. An end-to-end ER experiment for 2 snapshots was presented using the generalized ER machine learning approach to categorize the hosts, which was highly successful. Future work should consider ER on the host segments themselves and embedding this in a prototype tool for end-to-end entity resolution. If you're interested in more details on entity resolution for the cyber domain, please check out these following references. On behalf of the CSIAC, we would like to thank you for viewing this podcast. We hope you found the content useful and informative. If you would like to provide us with feedback, please comment on this video or visit our website at www.csiac.org, where you can also find additional content to review. Thank you.
Did you know that CSIAC offers free monthly webinars featuring experts in the areas of cybersecurity, software engineering, modeling and simulation, and knowledge management? Come see leading industry professionals talk about industry practices and leading research. Make sure to visit www.csiac.org/webinars in order to subscribe to our mailing list and see when the next webinar series is available. There you can also watch previous webinar series to catch up. Visit www.csiac.org/webinars.